Alright, hey guys, welcome to your weekend notes. Happy Friday, Saturday, probably Sunday evening, would be my best guess. Hopefully it's not like Sunday at midnight. Fair warning, I've got two lovely ladies in here taking a quiz. It's Friday after school, so if they giggle, make fun of them later. Perfect. You really gotta watch today. We are doing something new called flowchart proofs. The idea is, the two common proofs that we were doing were confusing. They're confusing because they don't follow each step. Like, it's not this step, then this step, then this step, but it looks like flowchart proofs are going to make a lot more sense for us. Okay? So, this is actually a problem that you had. I copied this out of the notes we did one time. It's a two-column proof. You had to fill in the blanks, and we kind of walked through this together. I'm going to kind of re-summarize some of this for you, because we're going to do something with this. We're going to write it differently. Alright? We're given that angles A and B are right angles, right? That's what we're given. We're told they're right angles. We have to prove that they are then congruent. Right? So we kind of walked through this. I hope you guys remember this. Normally you write down the first thing that's given. Yeah, I know you like the little boxes that hide stuff. Alright, so our first given is that A is a right angle. That was given to us. But how many things were we given? Right. Yes, and I know you had said that out loud. We were given two things. We were told angle A is a right angle, and that angle B is a right angle. So we actually have to write them separately. See, step 1 says angle A is a right angle. Statement 3 says angle B is a right angle. Right? What both of those tell us? Statement 1 says if A is a right angle, then the measure of A is 90 degrees because of the definition of right angle. Okay? So this is stuff we've done before. This part is not new. Silly boxes. I don't know why I didn't move those out of the way before. I didn't like them there. Let me fix my screen here real quick. There we go. Now I can actually see stuff a little bit better. Alright. We then knew B is a right angle. That tells us that B is 90 degrees. And we know that because of definition of right angle. Most people, honestly, when we're doing our proofs, we're okay with that part. That wasn't the hard part. Step 5 is where people were getting confused because it says measure of angle A is equal to the measure of angle B. And that was due to substitution. The problem is that what did we substitute where? And you actually have to go back and figure out which step is which. And we actually ended up taking this 90 degrees, replacing it with this angle B. Because measure of angle B is also 90 degrees. And then, of course, the last step is pretty easy. If the measures are equal, the angles are congruent because of definition of congruence. But do you see how, what makes it difficult is that we didn't go step by step. Hang on, let me get a better color here. Yes, I'll use pink. Whoever just said use pink, we'll get to the pink. Alright, what makes this difficult is we didn't go, A is a right angle, so it's this, so it's this, so it's this, so it's this. Two column proofs are ugly because they don't work like that. They don't go step 1, then step 2, then step 3. We went step 1 to step 2. Then we kind of started with step 3 on its own and went to step 4. Then we used step 2 and step 3 all to get to step 5, and it's just like, I don't know what's connected to what. This is why a flowchart proof is going to be beautiful. Alright? I keep saying flowchart. I hope we all know what a flowchart is. Flowchart's like a bunch of bubbles, and you have arrows pointing to tell what is what. So, like, you could have, if this is step 1, you could then go to step 2. A lot of times these are like yes and no. So, if you did a good job on step 3, or step 2, you go to step 3. But if you did a bad job, you need to go back to step 1. And that's the idea of a flowchart, is just bubbles and arrows. It tells what goes to what. Obviously, our flowchart proof is going to look a little prettier than that. Alright, so I'm going to go back to that one we just had. We were looking at, oh, it's up here. We're looking at something called the right angle theorem. So for my flowchart proof, I'm going to title it. This is the right angle theorem. I was given that angle A and angle B are right angles. And I have to prove that angle A is congruent to angle B. That's kind of my title, right? The idea of a flowchart proof is I can kind of start with everything. This gives me two givens. I have that angle A is a right angle, angle B is a right angle. Those are both equally important. There's no reason why I should put one ahead of the other. So I'm not. I'm going to put them side by side. Angle A is a right angle, and angle B is a right angle. And they're their own little bubbles. They are equal, so they're at the same level. How did I know those two things? How did I know that A is a right angle? That doesn't say art, by the way. I know y'all are looking at that. Oh my gosh, Miss King, you can't write anything. Angle A is a right angle. Get over it. And angle B is a right angle. How did we know that? I hope you said given, because that's exactly how we know. In a flowchart proof, we write the reasons beneath the statements, all right? So your statements go in a bubble, and the reason is written right beneath it, all right? Now I can kind of deal with these ideas separately. They're not the same idea. They're two separate ideas. I'm going to deal with them separately. What do I know if angle A is a right angle? Well, I know the measure of angle A equals 90 degrees. And how do we know that? What's the thingy that says that we can do that? Yes, that is definition of right angle. The other side works the same. Angle B is a right angle. That tells me that the measure of angle B is 90 degrees. And the reason for that is definition of right angle. So you see the difference so far? Instead of going in one single line, we've got two lines going on because we have two very separate ideas. The next step is where they merge together. This is where I'm going to substitute in, instead of this 90, I'm going to write the measure of angle B. So it takes both of those bubbles. See how I draw an arrow from both sides? It takes both of those bubbles to tell me that the measure of angle A is equal to the measure of angle B. And I know that because of substitution. I use substitution. Scroll back up a little. Okay. What you're looking at is our proof so far. It looks nothing like the proofs we've done before. Nothing at all. But this is a proof. Other than my ugly handwriting, this is a formal mathematical proof. All right, we started with our two separate ideas. Angle A is a right angle over here. We started with angle B is a right angle. And then we said, what do each of those tell us? Then we merged them together. Remember the last thing we're trying to show? And that comes directly from this bubble, that angle A is congruent to angle B. We know that by definition of congruence. That's how we know that. That is a flowchart proof. Okay? So let me make this full screen so you can get a big idea. I know, really, really tiny. I'm sure on your little phones, you all complain at me. I don't care. We had our two columns. It made no sense because the steps did not follow directly. But down here in our flowchart, I can follow the ideas. I follow the flow of information to see what flows into what. All right, so take a moment. Let that soak in. How are we doing on time? Look at that, guys. It's only been 9 minutes. I know, you hate me. I don't. All right, so flowchart, right? The idea is your ideas literally flow where they're supposed to be. All right, we're going to look at another one. And then that's it. I know you guys are like, but I didn't want to spend an hour of my weekend. I hear you complaining all the way at my house. I don't care. All right, one more we're going to look at. If I can find where I put my notebook. All right, this is another two-column proof we've done. All right, let me put this up full screen so you can see the whole thing. I know it looks crazy and complicated, but this is what we did, guys. We did this together already. You may not have understood it, but we definitely did it. This one is called the congruent supplements theorem. And it says if two angles are supplements of the same angle, then they are congruent. Here's what we're given. We're told angle 1 and 2 are supplementary, angles 2 and 3 are supplementary. So you can see from our picture, right? Those are on line, so they're supplementary. We have to prove then angle 1 is congruent to angle 3. All right, so see if you can follow my colors. Watch this. Step 1 says that angle 1 and angle 2 are supplementary. But we don't talk about that again until step 3, where we say they add to 180. And then we don't use it again until step 5, where we do substitution. This is what makes two-column proofs silly. We skipped this step. Like, why was that step even where it is when it has nothing to do with the steps around it? All right, we skipped this step. But notice those two were together, right? Step 2, so angle 2 and 3 are supplementary, which tells us they're add to 180. And then we also use that one in the substitution. I mean, it's silly. It's so ridiculous. So we're going to take this and we're going to translate it to a flowchart. And this is exactly what you're going to do on Monday. I'm going to hand you a proof, and it is going to be done. But it's going to be in 2 columns, and it's going to be ugly and confusing. Your job is to convert it into a nice, pretty flowchart, where it's going to make a lot more sense. Okay? So, we're going to convert this. My board is terribly misaligned. So I'm going to title it, this was the congruent supplement theorem. Remember, a theorem is something that needs to be proven, which is exactly what we're doing. We were given a couple of things, right? Angle 1 and angle 2 were supplementary. We were also told that angle 2 and angle 3 were supplementary. We had to prove that angle 1 was congruent to angle 3. So that's all the starting information. This is all kind of like my header, if you will. We do typically put it in the center of a flowchart proof to kind of give us the idea of what happened. All right? I'm going to start with my 2 givens. Notice I said 2 because weren't we given 2 different things, right? So I know angle 1. Let me write out and because I know you guys hate my and symbols. Angle 1 and angle 2 are supplementary. How do we know that again? What tells us that? Yes, I hope you said given out loud. If people are making fun of you. All right. What do you know with the other given, right? Angle 2 and angle 3 were also supplementary. And that was another given. Right? Those 2 things, they stand on their own. They're not the same thing. I don't need one to have the other, right? It's like, okay, and some of you can probably disagree with me. Like, I need ice cream to have sprinkles. Like, I don't know about you guys, I do not eat sprinkles out of a can by itself. Maybe you're weird, but other than the weird people, I need ice cream to have sprinkles. But I don't need peanut butter to have jelly. Like, I can have just a jelly sandwich. I don't need peanut butter with it. Ranisha just said that's nasty, I think. But that's fine. We'll ignore her. The idea is these 2 ideas, angle 1 and 2 being supplementary, and 2 and 3 being supplementary, are separate. They are not attached. They're not together at all. They both tell us something. I'm hoping this part we've got okay, right? What does it mean when 2 things are supplementary? Yes, they add to 180. So the measure of angle 1 plus the measure of angle 2 is equal to 180. And we knew that. The reason we knew that, the reason we were allowed to say that was definition of supplementary. The exact same thing, the other statement we were told that angle 2 and 3 are supplementary tells us that their measures add to 180 because of the definition of supplementary. So far in this proof, we eventually need to get to say that angle 1 is congruent to angle 3, but I have 2 very separate ideas right now. I've got 1 and 2 add to 180, 2 and 3 add to 180. I'm now going to bring those ideas together. Now, I know this looks almost exactly like the last one so far. I don't want you to get stuck on the idea that it's always going to look exactly the same. The idea with flowchart proofs is that they will look like the information is. Okay? So they don't always have to look the same. And I'll show you what a different one looks like here in a few minutes. But this one looks similar to the first one, but they won't always look the same. All right? But I do see, since they both equal 180, then they equal each other. And do you remember what property that is? That says if A equals B and B equals C, then A equals C. Does anybody remember that one? Maybe. Checking your notes. Thinking. Waiting for me to get tired of waiting for you to think, and you're just going to tell me anyway? Yep. It's the transitive property. Transitive property says if two things are equal to a third thing, then they're equal to each other. But notice my arrows. Guys, my arrows are so very important. All right? I had to take both arrows pointing to that bubble. This bubble that I just wrote right here could not be formed without both of the ideas above it. Okay? Transitive. Silly undo button. Okay? Both of those arrows must be there. The idea with the flowchart is it tells me where all the information comes from. To get this last statement, measure of 1 plus measure of 2 equals measure of 2 plus measure of 3, I have to have both statements above it. Not just one of them, both of them. Here's where this proof gets fun. All right, if you remember how we did this, remember the idea was we need 1 and 3 to be equal. We had to subtract off angle 2, but we had this really weird side step. We go all the way back to our 2-column proof. Remember this step? Everybody hated this step. You remember it. So the measure of angle 2 equals measure of angle 2 because of the reflexive property. Reflexive says that something equals itself. We needed to make sure that we were very clear that I can subtract angle 2 from both sides because it equals itself. But if I'm looking at this 2-column proof, right, step 6 is where I'm looking at. Did I need anything above it to know that? No. Okay? The idea is the fact that the angle 2 equals itself did not come from any of this stuff. None of that was important. I could say at any point in time that the measure of angle 2 equals the measure of angle 2 because of reflexive. I don't need anything else. So in my flow chart, it's over here to the side. And there is no arrow being drawn to it. I didn't need any of that information. But I have to have it because I have to use it. I now can put together that bubble and the bubble above it. Together, I need both of those ideas to know that the measure of angle 1 is equal to the measure of angle 3 because of subtraction. Right? Because I subtracted the measure of angle 2 from both sides, right? It cancels out. But I couldn't do this without the reflexive property here. Okay? Let me get my ugly scribbles out of the way. There we go. That's what you should have, all right? The rest of it is scribbled on top of it. So this little blue bubble over here, right over here, it really is just kind of hanging out there by itself. We use it for the yellow bubble, but it doesn't come from anywhere. It's just knowledge we know. And now, everybody's favorite, most easiest step. If the measures are equal, the angles are congruent. Angle 1 is congruent to angle 3 by definition of congruence. Okay? So if we look big picture at this, what does this whole thing look like? Okay, let me move this out of the way. Okay, it looks like a spider web, Rennie, she said. You know, the idea is you can kind of follow what came from where. I can see this one down here, the reflexive property didn't come from anywhere. I just knew it, because I'm brilliant, and so are you, by the way, right? I could see that for a little while, I had two separate ideas, and then they came together to make one idea. And then I could see where that flowed to, where all the thoughts went, right? It's a much, much more visual approach to proofs. The problem becomes you still need to know your reasons. You still need to know your definitions, all of those rules we had. You can't forget them. You can't forget what transitive is. You can't forget what substitution is. Those things, guys, you still do need to remember. Okay? But for the next couple days, you don't have to come up with that on your own. Your job is to translate. You guys know what I mean by translate? Right? Like I said, English to Spanish to French. The idea is you're going to translate from 2-column proofs to flowchart proofs and back and forth. That's what your job is going to be. Okay? Let me look up here real quick. And then, let's go check out Google here real quick and see if I can just show you what it looks like on a real flow chart proof. All right, let's just see some images of what a flowchart proof might look like. Okay, some of them are a little crazy. If you ever go and Google this, you'll see the idea. All right, this one, you can actually see they go sideways. I go like from top to bottom. This one goes, let me pull up my marker here. This one goes from left to right. But the idea is the same. You can kind of see they started with two separate ideas. They flowed together. It took three things to make this step here. All right. So flowchart proofs, they are so much more visual. They're so much better. Much better. All right. You can see another example here. Full size image. All right. That they start again with two ideas. They have this idea. They know this. You can kind of follow where their information goes, and then it goes all the way across. So it's very visual. It tells you where things are coming from. My strong suggestion, again, assuming this is not Sunday night at midnight, which it shouldn't be, is that you let this sink in for a little while, and then at some point you come back and watch it again. I know, oh my gosh, Miss King, I already spent 21 minutes and 17 seconds watching your video. I don't care. You need to know what to do. All right? If you have questions, you call me. Email is probably the easiest way to get a hold of me. Hope you guys all know my email, kking@earlycollege.org. It goes to my iPhone. I do check it. All right? Let's do the, I don't know what kind of funny thing to say. Do you want candy? Nobody really wanted candy. If you have listened this far and you have not turned this recording off, if you come find me Monday morning, and you can tell me what the reflexive property is, what it means, I will give you a merit. Merit! Yay! Monday morning, before school. I don't have breakfast duty. I should be in my room. Tell me what the reflexive property is, and you can have a merit for being educated because you're just that awesome. Do have a good weekend. If you're watching this Friday night, go have fun. Enjoy the weekend. Bye.